This is section 4.6 part 3, where we are going to add and subtract complex numbers. Complex numbers are a number that has an imaginary number in it, so it has that imaginary aspect to the number. And the standard form, which you see written here of a complex number, is a plus bi, where this I represents the imaginary aspect of this complex number. I stands for imaginary, and A and B represent real numbers, so they can be any number. So we've got a couple examples for you. Examples of complex numbers are 4 plus 3i, where 4 is a real number, 3 is a real number, and I is the imaginary aspect, or 7 minus 2i. Both of these are in standard form. So what we are going to want to do is simplify this problem so it's written in standard form. So it looks like this, where the number with the imaginary aspect attached to it is lasts, and the constant, the real constant, is first. So we've got 9 minus the quantity 10 plus 2i minus 5i. Before we start this, let's go work with what we know. Alright, so I'm going to basically do the same exact problem, but instead of having these i's, I'm going to replace them with variables x. So I've got 9 minus the quantity 10 plus 2x minus 5x. This might seem a little bit more comfortable for you to deal with. So let's simplify this problem first. What would we do? Well, we've got this minus in front of the quantity, so we know that's like a minus 1. So we need to distribute that to each term inside the quantity. So I'm going to have 9 minus negative 1 times 10 is negative 10. Negative 1 times 2x is negative 2x. And then I have minus 5x. So now I can see I've got some like terms here that I need to simplify. And I've got 9 minus 10 gives me negative 1. Negative 2x minus 5x gives me negative 7x. So if I wanted to work with this problem, my final answer would look like negative 1 minus 7x. Well, guess what? When you're working with complex numbers, the same rules apply. You can really think of this I just like a variable, just like pretend it's x, and you would do the exact same process. I'd want to distribute in this negative, or that negative 1, and I'd get 9 minus 10 minus 2i minus 5i. My constants and my imaginary numbers are going to get combined, so the constants get combined with the constants. Those are my like terms, so 9 minus 10 gives me negative 1. Negative 2i minus 5i gives me negative 7i. So my answer is going to be negative 1 minus 7i, and you can compare that to what we did here, and it's exactly the same process. So to repeat, the I, which represents the imaginary number, holds the same properties as a variable, so you just work with it just as if it was a variable. So let's look at one more of those. Come down here to number 2, and we've got negative 11 plus 3i plus a quantity 4 minus 6i. So we have two complex numbers in standard form, and we can basically use our properties of addition. We can change this, add the opposite, so I have all addition, so I can use the commutative property of addition and regroup, and I can regroup 11 with 4, and I can regroup 3i with negative 6i. Now I've got like terms grouped, so I can see negative 11 plus 4 gives me negative 7. And 3i plus negative 6i gives me negative 3i. So my final answer is negative 7 plus negative 3i, or if you wanted to write it, negative 7 minus 3i, that's perfectly acceptable as well. Alright, and that's the end of part 3.